Working with parallel circuits is one that requires adding a little bit extra math work because of the way that is presented and calculated. Some of the formulas used with parallel circuits gets to be a little confusing, so let's see if we can't get started and analyzing how these parallel circuits are actually working. I'm going to draw first our power source. And from the power source I'm going to draw two horizontal lines, and this is going to be known as our main feed lines, and they're going to be working with branch currents. Here's our first branch, so that by looking at this circuit the way it is a complete circuit. We do have current that flows like this, and as a result this is actually going to develop its own current in this particular circuit. Let's add one more onto here. This is going to be our second branch. So from this one, which is our first, this becomes the second. We're going to talk about going from the resistance and the voltage and talk strictly about the currents, which I'm going to relabel these as I sub 1 because it's the current going through first resistor. I'm going to label this one as I sub 2. One of the easiest way to calculate the branch currents is to actually take the resistance into the voltage. Use Ohm's law. It's an inverse relationship, and we'll take a look at this in other examples for parallel circuits. So this very first one would give us our branch current for this unit. If we take the same formula and apply it to this one, it'll give us the branch current for this particular load out here. If I were to add more loads, for example out here, I would now have an I sub 3 for a third load sitting out here. Looks like this. Okay, so now we have the complete parallel circuit. It has 3 branch loads out here, and these are called branch currents, 1, 2, and 3. To calculate the total amount of current, which sits right here, and it's measurement, we would call this I sub t. In this particular case, instead of having voltage drops, we're going to have branch currents, a little bit different from series circuits. In the case of this one, for the total amount, which is Kirchhoff's current law, we're going to say that the total amount of current is equal to the sum of the branch currents. We now have I1 plus I2 plus I3. Okay, so in this particular example, on a parallel circuit, we've used 2 laws. We've used Ohm's law to calculate the individual branch currents. We've used Kirchhoff's current law to determine all of the total amount of the current with respect to the addition of all 3 branch currents. And remember, we could always just have 2, we could have 4, 5, any number of branch currents on here. And the addition of all those branch currents will equal the sum current right here.